Hello. Welcome to the session on State of Python. It's going to give an overview of the Python language and how the Python ecosystem is and what's the state of affairs in different Python interpreters. Following this talk will be a talk by Nick Coughlin, who would be presenting about the community aspects of CPython. So with these two talks in mind, I think you will get an overview of both the technical aspects as well as the social aspects of the Python. So I'm Senthil. I am a Python code developer. I work on mostly the standard library, help fix bugs and feature requests in networking-related modules. And I have fun doing that, so it's an enjoyable thing for me. So let me straight go ahead with the Python talk. Oops. So Python, seeing Python as a language reference separate from the implementation. So what do I mean by that is like Python is as a language reference, which has its own keyword, its own definitions of how the keywords operate, and then what the language definition is supposed to do. If you write a piece of code, then if it is called Python, it's separate from the implementation. The implementation which we most commonly use is the CPython. It's written in C. And CPython is just one of the implementations. And so is the other implementations which many of us know are PyPy, Jython, IronPython, and CLPython. CLPython is not probably the most famous of ones, but it's a common list implementation of Python. Not many have used it. Like it's just a hobby project of some person. So a Python, your implementation can be called a Python if you write one following the definitions of the language reference. And if it follows the definition of the language reference, it'll be called a Python if it follows it properly. So it can be any implementation that you can also write. So the first thing to keep in mind is Python as a language reference separate from the implementation. And CPython is one of the implementations. And reference implementation, the CPython, which most of us work on, Nick's sitting there, Raymond's here, and most of us who work on is the reference implementation, because it's the BDFL Guido overlooks the development process and guides us in terms of what the decisions to be made and if it's correct or not. And that's what most commonly used by all over the people in the world. We have a Mercurial repository at hg.python.org. It's the branch by name CPython, which has all the code for the implementation, and it's under active development with around 30 developers, I would say. So that's the reference implementation, which can be considered as the guiding implementation for many of the other interpreters to catch on. Part of the reason being CPython is at the stage of 3.3, which is backwards incompatible with 2.x, and it's going ahead with the 3.3 release. And other implementations are in the 2.x stage as well, who are planning to catch up with the 3.x series. So what's the state of affairs in the CPython release schedule? Like currently 3.3 version is being planned, with Georg Brandl being the release manager. And it usually happens in terms of alpha, beta, alpha 1, alpha 2, beta 1, beta 2 release candidates 1 and 2, and then the final release. It's the 3.3 is supposedly, when I last checked the PEP, it's supposedly to be released during the March 2012 timeframe. And then 3.2.2, which is a bug fix release. Usually the .1 releases are usually the bug fix releases, which happens. The 3.2.2 got released very recently, it's in the release candidate stage. The release manager again is going to be the Georg, and 2.7.2, which is the last active line in 2.7 series, is planned in, the dot release need not be the last one, but 2.7 is the last active release in the 2.x series. It's going to be released in June. It was released in June 2011, and we don't have the next when it's going to be updated. 3.1 and 2.6 is also being maintained, but they are mostly in the security fix mode, wherein if some security bugs come up, they get fixed in 3.1 and 2.6 series. The Windows installer and the Mac Windows installers are done by Martin von Lois, and the Mac installer is done by Ronald or Ned Daly, who's again a new he joined like last year, NetDairy. So that's how the CPython release schedule is. And the important thing to remember in this slide is 3.3, which is being actively worked on. And in the next couple of slides, I will show you some of the interesting things which have gone into the 3.x, but still we have a lot, 3.3. But still we have a lot of things to go in 3.3 yet. So, yep, this is interesting to remember. We see that the latest of Python is in Python 3.3 series, and how's the Python 3 progress is happening. You can see that this site called py3support.appspot.com lists all the major frameworks which have had support for Py3. We can see that it's the 3.x series is improving fast. Like a lot of modules are getting supported in 3.x. You have setup tools because the distribute, which is the packaging tool, is a fork of setup tools, and it supports Python 3. There's pip, virtual env, nose, paste, paste deploy, simple JSON, Jinja. You will see that the templating languages, the numeric libraries, the SciPy and NumPy all have good support for Python 3. What doesn't have good support for Python 3 yet is the web frameworks world, wherein the WSGI spec hasn't been sorted out clearly yet. There's a lot of discussion happening, and once it gets stabilized, we'll probably see the web frameworks world move much faster. And probably I think that, it's my opinion, that once the web frameworks world catch up, Python 3 support's going to be moving faster. And the best thing to happen in Python 3 as of now is, in my opinion, the setup tools support for Python 3, wherein the recent distribute and setup tools have a keyword by name use223, which uses the lib223 module to do an on-the-fly runtime compilation to Python 3. So if you have a same code base and if you write it in such a way and you use Python 2 setup.py build and setup.py install, your application will be installed against the Python 2 interpreter. And if you write the code base in such a way and use the keyword called use223 is equal to true, your distribute and setup tools will take care of on-the-fly translating into Python 3 code and then installing it against the Python 3 interpreter so that your application is ready. Probably that's the best thing right now. And that's how the state of affairs is in Python 3 world, and it's moving fast. I don't know why it's okay. So yeah, that was a graph which showed the number of packages which have the Python 3 support coming up. So what's happening in Python 3.3 at the moment? Python 3 launcher for Windows, which is PEP 397. The PEP was written by Mark Hemmond, should be here in the crowd. And it was implemented with Vinay, and it's basically a launcher for Python scripts on Windows. So on Linux, we are used to the shebang concept, wherein you have a Python, you can give it an executable mode and then run that Python script. But in Windows, we don't have that. But this PEP introduces that capability, wherein it installs a launcher which is going to be bundled with your Python installer, and that can associate itself with shebang lines on Windows. Okay, it's not a concept which we all hear commonly. I'm not sure if there are tools otherwise doing that, associating shebang lines on Windows with something, but this one does that. It not only, so it follows all the details of the man get exec vc, which is like what the shebang lines are supposed to do. If you point it to an env path of the Python 2 interpreter, it will do it. So it's an installer it's a launcher for Python scripts on Windows, which will associate with the Python which you use in the shebang line. So if your script is written against Python 2, it will call the Python 2 program. If it's written against Python 3, it will call the Python 3 program, whatever your shebang lines is. That will be shipping with Python 3.3, and there is a launcher already available for download, which you can download and test and provide feedback both at bugs.python.org and then Python dev mailing list. A fault handler module, which was implemented by Victestiner, which is in place in Python 3.3 and has helped detect a lot of bugs in the build bot. it can be enabled for different kind of signals and can be triggered by ourselves using the code, and can also be used in the command line switch -x fault handler. -x was a switch which enables the keyword on the command line, which was probably introduced in Python 3.2, I believe, 3.2 or 3.1. When your fault handler module is used, if your script presents with a segmentation fault because of some C API related failure, it will give you the reason, a very minimal feedback in terms of where did that particular function got called and why did it occur. So it helps in debugging the C code as well. So that's where the fault handler module comes to use, and that's in place in Python 3.3. So in terms of the overall framework supports, as I said already, NumPy supports it. Support is not fast in web framework world because there's a need to sort out the WSGI spec. I'm not sure how long I've been saying this, but if anyone has an idea that anyone has listened to the Python 3 talks earlier, everyone says that, and it's going on, and hope that will soon get settled. Closing the gap of 2.7 and 3.x will help migrate faster. I mean, it's happened a lot in terms of there are many features already backported to Python 2.7, and if you write your code in Python 2.7, your migration step will be like targeting directly to Python 3.2 or 3.3, whichever is latest. You may well skip the 3.1 version. It's not really a harm, but it's like your movement will be much faster and easier. Distribute, the fork of setup tools has a support, and that's the best thing to happen so far. For many cases, the migration will be as easy as with fly 3, okay, will be easy to convert it on fly with the use 223 is equal to true keyword flag. For example, there was a debugger by name PUDB, which I like it in terms of because it provides a full screen debugging capabilities. And I cloned the GitHub repository and used the 223 keyword and just tried compiling it. It fixed most of the problems except for some Unicode related stuff which you have to be aware and then fix that, and your tool is ready for Python 3. And that's as easy as it is. Support is steady and moving forward with target of 2.3 on 3.2 or 3.3. So that was the state with the CPython. And now let's quickly jump to Jython. And in this talk, what I've categorized is like CPython, Jython, IronPython, and then PyPy. PyPy seems to be the most interesting thing happening at this moment in time because there's a lot of news and a lot of interesting topics happening all around. I'll quickly go through all of them, and it'll be a fairly high-level introduction only. So Jython is like, and this will be like giving you some introduction to new persons as why would someone use Jython and someone use IronPython. Jython is an implementation written in Java, and the language syntax and semantics are same as Python because it's a Python language implementation. And Jython has also moved its repository to Hedgie, the Mercurial repository hosted at hedgie.python.org, so you can clone it from there. I saw the check-ins and everything which was made. When they last checked in the entire code base from whatever repository they were managing, that's when it was, like 3 months ago. So you can say that it's not really active in terms of daily 30 commits being made, but it's like in a month or so, some commits will be made. So it's in progress, but it's not like developers throwing on it daily committing code every day. So why Jython? Java and Jython, they seamlessly integrated with Java and import and use any Java class. That's the best part of Jython. Okay, except for some standard modules which uses the C types and the Python related modules, Jython programs uses Java classes instead of Python modules. So you can have that. Eclipse, of course, provides some sandbox plugins where you can do an interactive session with Java in terms of look at what the Java, like have a dir-like capabilities for Java. But with Jython, it becomes easier. So you have your Jython and then compile your Jython against the Java library which you are going to use, and then have this REPL-like structure which you want to test against, which is very handy for a developer to see that if a particular method is present in a particular object or class or everything. So Jython provides that, and you would want to use Jython for that. And why would you use Jython? You're from the Java world and you do not want to feel away from the home. It provides the dynamic compilation for Java bytecodes and ability to extend the Java classes written in Jython. And optionally static compilation with applets, servlets, and beans, which all you can write it in. And the last thing is this, okay, you are a Python programmer and you want to learn Java, which is also again good. Like you can get started with Java in the Python way, because as a Python programmer, you will get used to the REPL and then introspecting the objects and then everything, and you want to know that. And you want to do line by line instead of like writing a full program and compile with the Java C and write it. So Jython provides a good stepping stone for you to get into Java too. So these are the things. And one of the features would be like it's prototyping in terms of writing a small Java code. Investigation of classes, you can do that. And glues together with libraries already written in Java. So you can write a part of a program which is Python-like, and then you have libraries written in Java, and then you can mix them together. It runs on any JVM which is above 1.1 version. It's truly multi-threaded because the Java hotspot, which is the GIL, which removes the GIL. So you don't have GIL in that, and you have an application which is GIL-free. Okay, it's all about concurrency. Dicts are built on top of Java's concurrent hash map. But the downside of this is, so this is an example of the introspection capabilities. Like you have from java.util import date, you have a date, and then syspath will include the class path also. So the downside of this is, have some more examples of how subclassing Java can be. Like have abstract windowing toolkit. I have imported the abstract windowing toolkit and written a Python program which works on the abstract windowing toolkit concept. And I can execute it and show, but it's just a window which looks for the standard Java applet window. So how's Jython doing? The current Jython is compatible. Okay, let me complete the previous sentence. It's truly multi-threaded, it's concurrent, and then it doesn't have GIL. The downside of that is it's slow, okay? So Jython is it's slow, slow compared to CPython. I have the next slide which is covering that. So, but let's come back to how Jython is doing. Jython is compatible with the CPython reference implementation 2.5.2, which means that your with keyword, which is one of the major things in 2.5, is supported, apart from the others like decorators and everything. HG version targets at 2.6. So if you clone the Mercurial version, it targets the 2.6 version. There are popular frameworks which supports Jython, like Django, Pylons, SQL Alchemy, and the scripting support in Oracle WebLogic and the IBM WebSphere application server is provided by Jython. So if you use any of these big frameworks, then Jython is available as a plugin language. Virtual env and easy install are all available in Jython. So on your platform, you just do an apt-get install Jython or download the jar file and then install it. There's no mobile edition so far, so it's not suitable for Android if you've been thinking of that. It's targeted with Java Standard Edition in mind. Performance to CPython is comparable to slower in general. Multi-threaded applications can be faster because there's no GIL. The good news is it's not just an extension language, but a complete programming language suitable for application development. So that's the one to keep in mind. So let's go with the IronPython. Okay, IronPython is an implementation of Python language targeting with the .NET framework and Mono, which is good in the Microsoft world. I was surprised to see that the IronPython is in 2.7 compatible. Okay, that is good work which is going on. But I don't know, for whatever reasons, there is like a lot of, it's not in news wherein a lot of people talk about IronPython. Okay, I'm going to rush through the slides, so bear with me, sorry for that. Okay. So there is like the surprising thing which I noted when I prepared the slide is like IronPython is moving fast, as in they are compatible with 2.7 code. It has good features. C# is an excellent language and it works really well with the C# thing. And there are a lot of frameworks which I have supported too, but not the web framework side, but the other sides. Like you have robotics, Microsoft Robotics framework supported with the IronPython, and it's pretty good actually. In terms of technology-wise, I'm not talking about the social and the other licensing part. So it's 2.7 is available for Windows platform as desktop and server apps. Its prerequisite is to install the .NET 4.0 and Silverlight 4. So when it has that support with Silverlight 4, you can see that the Python can be run on a browser too. So they have a good demonstration of how Python with the Silverlight 4 is used on browser. I have a link for that. And on Linux and Mac, it's available via Mono and Moonlight plugin, which is not as good as anything. As in, like, it's not usable at all. Why should you be interested? Okay, this is an important point. Corporate credibility when your company uses .NET technologies. I mean, it's hard to know, hard to think like that, but it's true. In fact, there are companies, shops which use Microsoft technologies, and they have trusted the Microsoft technologies that it works for them. And now, if you want to pitch Python in terms of slowly extending the application development, you can pitch IronPython, that it's a Microsoft product and it comes well with the bundle, so it can be extended with that. .NET frameworks built in Windows Form support, and it's easier to extend than CPython, okay? Because, so even IronPython doesn't have the global GIL because it's run by that virtual machine of C#. Silverlight support is present, which makes it suitable for implementation on browsers. So here's an example of using import CLR, common language runtime, and then add reference to the system Windows form, and then you import a message box and say hello world. You will get a native Windows applet saying hello world. Framework support, NumPy, SciPy support via Ironclad. Django support is only with a lot of hacks. Example applications, this IronPython.net try has a lot of web-based applications which you can see with written using IronPython. There's a Silverlight example applications too. Microsoft Robotics Kit, mostly in C#, but you have a extension language available in IronPython. Then XNA, which is used for 3D games, has IronPython support too. PyPy is the most interesting thing which is happening. I'm not sure if there's a talk in PyPy in the whole of conference, but it will be good to have in any conference because we are going to see a lot of them in the coming conferences. PyPy is, again, Python. So if your Python is like if you install and you install PyPy and rename your user bin Python to PyPy, just instead of using a standard CPython interpreter, use the PyPy interpreter, and your program will probably work, unless it has some C-types module which is compiled. Even C-types have a lot of modules have support for PyPy, but there are like good 90% chance that whatever your program is, it's written in pure Python code or some standard C-type modules which is compatible with PyPy. It's going to work, and it's going to be faster. So that's the whole part of the project. The aim of the project was to make Python fast, and that's what they had been doing. And it has shown pretty good progress in terms of the performances. So just to give a recent anecdote, like 2 days back, there was some person who was comparing Python with Node.js and JavaScript, and he solved a lot of Project Euler problems and said that Python is slower than Node.js because Node implements, the JavaScript V8 engine implements this just-in-time compiler which provides the speed up. And someone suggested that they use PyPy because it also provides the runtime just-in-time compiler. And he found that the PyPy was significantly faster too. So here you have this Python which is faster than V8 JavaScript, which is faster. So, oh my God. Okay, so what the PyPy is? PyPy is a very interesting project wherein you have a translator as well as a runtime interpreter. The interpreter is a RPython. How it is faster, PyPy is nothing but the Python written in Python. And how it becomes fast is, there is the just-in-time compiler. And if you want to go know the basics of just-in-time compiler, it compiles into a native bytecode at the just-in-time, at the moment when it's running. Okay, so there is the RPython restricted Python interpreter, which is fast because restricted Python interpreter, I believe they wrote this interpreter for implementing the language. So they didn't care about many different keywords. They didn't care about many different decorators, generators, and everything, all the concepts. It's just a restricted Python which provides speed, and it's helpful to implement an interpreter. And that interpreter converts whatever source code which you have written in Python to an RPython-based source code. And then there is a translation toolchain which can translate this RPython code into the native Python code, which is C-Python-based, C-based API, which is what the PyPy default engine is. Otherwise, it can also write languages which can be run on Java, on C#, and then there is plans for writing JavaScript. So PyPy is like a toolkit for writing just-in-time compilers at the runtime for any language which you want, which is like mind-blowing. It's interesting. And PyPy has been successful in doing that. So you have that, so it's like the program which is a PyPy interpreter converts it to a CPython program. I don't know, there is like my resolution problem. It was good when I looked at my laptop. So this PyPy translates to the PyPy interpreter, which is based on C, and it runs on the native POSIX environment. So it is compatible with 2.7.1, which is like very latest. Okay, the plan for 3.x support is very far, which can be perfectly excused. Okay, there's no problem with that. But it's very close with CPython's 2.7 series, and it runs on 32 and 64-bit Intel x86 architecture and includes the STM. I'm sorry for that. Okay. Okay, in terms of framework support, there's plenty of support for the frameworks. There's Pylons, Piglet, Nivow, Django, everything supported in PyPy. Did you hear the recent news that one of the PyPy developers who works for Kumaran, who just used the PyPy interpreter instead of CPython interpreter, which Kumaran uses, and the site saw a significant speed up. There was a huge speed up in the Kumaran, and Kumaran.com or Kumaran.net. Okay, that's the capabilities in terms of it has really sped up a lot of stuff. NumPy integration is progress, and almost anything that does not involve C-types module is guaranteed to work with PyPy. Performance-wise, let me see why this thing.
Only a couple of minutes, mate.
Okay, that's fine. Yeah, so here's the CPython performance for different frameworks. And except for one, which is like elementary, I believe, most of them, the lower is the better. Most of them use a significant speed up in terms of when using PyPy. So that's where the PyPy has been really, really fast, and it's good. And so it's easy to, it's pretty interesting as a concept in computer science too, writing translators. They've been trying to remove GIL using a software transaction memory. It's kind of like, as far as my understanding goes, it's like a database support, and some transactions and then commits are all database terms. And they're bringing it to the GIL world, wherein you can have STL concept, which is like every transaction is protected, and then when it's complete, it's committed. So there's the speed, it's removing GIL using software transaction memory. It's been a concept around for many times. It's been tried in Haskell, I believe, but many people aren't really sure about it. But it's a good thing to try because it's pretty interesting, and who knows how things go. So that's it, and the previous slide showed that the speed comparisons, like it's available at speed.pypy.org, which shows that how Python speeds up. And the final slide, I believe, that is what's the future. I said, like, it's Python the language. We all will be writing Python, and you will not care about what the interpreter you will be using. It's from my home. I don't know. Choose the implementation which suits you most. Work alongside with other languages and frameworks. That's the future, and you should be happy that there's so much of things going on in the Python world. Thank you. Have any questions? Okay.
So do we have any questions? We've got room for a couple.
Sure.
Do we need the mic up? Yeah. I don't know. Does that work? Good?
Yeah, no, turn it on.
How does it turn on?
How have I switched to that? The big button on the bottom.
I swear I was pushing that. There we go. Thank you.
Okay, so you've mentioned, you actually showed the benchmarks for PyPy being faster than CPython for most of the benchmarks there. And runtime speed is obviously very important, very useful in practical terms. But the other space where at least I can see potentially it's faster is development time, because you're not dealing with C, you're not dealing with memory leaks. The same reasons that people use Python instead of writing code in C. What's the future of PyPy with relation to CPython? I mean, it is a self-hosting version of Python. Is there a point at which, it's not now, obviously, but is there a point in the near-ish or even distant future where PyPy becomes the reference implementation because it's self-hosting? Is that even something that's even remotely possible or on the horizon? Is there a time at which we say goodbye to CPython because we can get rid of C for the most part?
Okay, that's a question in my mind too, so I don't have the clear answer to that. But it's interesting developments happening in the PyPy world. And the CPython is more than just a Python language. It's a community of developers who are like working together with all the libraries and support. I think if if things work well together, it'll be the best. And we find that there are good developers both in CPython as well as PyPy sharing development time with each other. In terms of reference implementations, like it's my understanding that Guido dictates the development process and the community and everything. So wherever Guido is, might be the reference implementation, whichever side it's in. And perhaps practically PyPy may get used in a lot of projects. And Python 3.x is moving fast. So I see that Python 3.x is the much cleaner way to write the Python code, pure Python code. And it can be, the implementation, the interpreter can be PyPy when they support Python 3.
I'm here from America, or the United States, and I'm involved a lot in education of beginner Python developers, and the sticky, nasty part of that is Windows people. And I'm a Mac and Linux user, but when the majority of your students coming in are on Windows, it hurts when we have to help them set up their paths and stuff. And so the question is I know that there's a PEP for it, and I know Mark Hammond's in the room, and I've raised this publicly online in a few places, but what is the holdup with getting this out there? Does it need sponsorship? Are you the person we go to for this? I'm not the only educator who's run into
No, I
this.
didn't get the question, sorry.
So the question is I think it's PEP 397, authored by Mark Hammond, who might be in the room. It seems to be taking a while to get delivered, and I'm wondering if it needs sponsorship. What can you point me in the direction of making this happen?
Sure, it's already in place in Python 3.3. If you are talking about the Python launcher on Windows.
Whatever it takes to get Python installed on a Windows machine, XP forward, trivially for beginners, where they are not having to, these are beginning developers, how do we get more people into the community? Why are the beginning Windows users, who are the majority of the people in the world, having to fight their operating system? And this is only with Python. You don't see this with Ruby or other languages.
Okay, I get it. So I get your point, like what you're really saying, in terms of like some people have said that idle is not a suitable development environment on Windows, but it still is the only IDE available, shipped default with Python. PyLauncher, which is a project which is like available in the 3.x series, it will be a good idea to see that the 2.x version is available. I believe it's available in 2.x version also. It will help in terms of once your PyLauncher is installed, it will be much easier for a person to write the Python code in Windows and then double click on it to execute it, which will help save a lot of people the learning curve in Windows. Double clicking a Python code on Windows to execute it and see it in action is probably the best thing. That's cool.
Sorry, we have to wrap it up so that we can do the switch over. But thank you very much for coming out. And as a token of our appreciation, you get this handsome PyCon Australia mug.
Thank you.
Dishwasher safe, 3-colour. It's great. Collector's edition.
Okay. Thanks a lot.